So, number one, where does it start?
At +1.
Positive one. Okay, from there, where does it go?
It goes down 3 and over 4.
Down 3 over 4. That line look familiar? We are already one ahead of last time. Number two, where do we start? Positive 3. Okay, from there we go.
And over 1. I knew if you can make it a fraction, over
Yeah. You got to put it down 2 over 1 to make it a fraction. So it's down. You went down 2 over 2.
No, we just had
Went down 2.
3 over 2.
Oh, gotcha.
And that's it.
Yep, we've got to make it 2 over 1. So it's negative, so it's down 2 over 1. So that one is halfway there. Number 3. What do we have to do to that one? I'm guessing the first thing you did was add the 3 to it, right? So y equals 2/3 x plus 2 now. You say you started at positive 2, and from there you went
Up 2 over
2 and over 3. Cool. And oh, so that one was correct. And number 4.
divided by 4.
Divided by 4. So y equals 4 over 4, just 1, right?
1.
Minus 1/4 x. Okay, so where do we start?
At +1.
Positive 1, and from there we go.
Go down 1. And go up 4.
Not familiar? Cool. And finally, to numero 5. Got to subtract 3x first. So you've got left with negative 2y equals 4 minus 3x. And then you divide by negative 2. Y equals, so it's 4 divided by negative 2. Negative 2. Positive 4 divided by negative 2 is a negative. Negative 3x divided by negative 2, though, is a positive 3 over 2x. Just put this number over that number. Negative divided by negative is a positive. So that starts at negative 2. And from there it goes 3 over 2. Not so bad?
Better than last time.
What's the slope of that one? Almost.
Negative.
There it is. Negative 2/3.
Okay.
That one?
3 over 5.
Up goes up 3 over 5. Perfect. How about that one? This is 4 over. This is down 2. So negative 2 over 4. Negative 1/2. What's the coordinate of this point?
-1.
3, right? Negative 1, 3. Coordinate of this point? 3 positive 1. If I am going to find the rise, what coordinate, the x or the y, describes the rise? The y. 3 minus 1 gives me 2, right? We're going to describe the run. Which coordinate describes the run? The x. Negative 1 minus 3 equals negative 4. So that would give me 2 over negative 4, or if I subtracted the other way, negative 2 over 4. Either way, it's a negative 1/2. The formula for that, slope, the letter we use to abbreviate slope, by the way, is the letter M. S is used for a lot of other things. M comes from the Latin word for slope, and I don't remember what it is right now. Yeah. So what this is, y coordinate of 0.2 minus the y coordinate of 0.1. So let me give you some points here. Let me give you the point 3, 7, 5, 1. So my slope would be, what's the y coordinate of 0.2? I'll do this, 1 and 2. So 0.2 y coordinate is 1 minus the y coordinate of 0.1? 7. Yep, you are correct. That's negative 6 on top. What is the x coordinate of 0.2? 5 minus 3. X coordinate of 0.1 is 3. That is 2. So negative 6 over 2 or a negative 3 slope. You're confused, eh? Okay, so how about this one? Where am I going to start? Negative 10 minus 5 on top, okay. That would be a negative 15. Three minus a negative 2 is a positive 5. Negative 3 slope. How about I asked you to find the equation of this line. The equation contains two things. One's the starting point, this thing here that's added or subtracted to the x. Where does this one start at? Negative 3, right? What's the slope? It's 3 over 2, right? Up 3 over 2. So y equals 3 over 2x minus 3. Not so bad? Kind of slick, isn't it? How about this one? It starts at positive 5 here, right? It's always the up and down that it starts at. Yeah, coordinates it's side to side, but for the equation it's always the up and down for graphing. So it's positive 5. Slope is negative 5 over 2, so negative 5 over 2. So y equals negative 5 halves x plus 5. How about that one? Starts out at positive 3, so plus 3 over here. And slope? Good stuff. I want to do. I asked you what the slope of that is. What is it? The number that multiplies the x is the slope. 2/5 or 2/5. Up 2/5. Right? Go ahead and give that one a shot. Graph the two of them together. So for the first one up here, we'll call it the blue equation. Where do we start?
We start at -1.
Okay, and from there we go
We go
up to
over 3.
over 3. And I'm going to do it again, up to over 3. Just to give me a couple of points to go off of. So we're going to pretend that line's straight. Okay, for the red one, where do we start? So 1, 2, 3, 4, 5, 6. And from there we go down 1 over 2. I'm going to do it again. And maybe one more time. There's a reason why I kept doing it. One, it helps me keep my line straighter and in the perfect angle. And also, there's a further ulterior motive here. What does that blue line represent? Yeah, all the solutions to that equation. Every point on that line, if I take its x coordinate and its y coordinate, like right here, this is x equals 1.5 and y equals 0, right? If I put that in there, x is 1.5, 2/3 times 1.5 is 1, minus 1 is 0. That's true. Any point on that line, I take its x coordinate and its y coordinate, I plug it in there, it's going to make that true. How about the red equation? The red line. Yeah, that's the solutions for the red equation. Any point on that line, this is 2, 5. If I put in 2 here, that's -1 plus 6 is 5. Any point on that, if I take its x coordinate and its y coordinate, it's going to be true. So what we're going to talk about today is something called the system of equations. The system of equations is two equations. And we want to find the values of x and y that make both true. On this graph, where would that be? Where they intersect, right there. Since I did this very carefully, I know that's at 6, 3. If I put in 3 here, that's 2, minus 1 is, or sorry, if I put in 6 here, that's going to be 4 minus 1 is 3. That's true. If I put in 6 here, that's going to be -3 plus 6 is 3. That's true. That point, 6, 3, makes both of those equations true. That is the solution to the system of equations. And for today, all we're going to do is we're going to graph those lines and see where they cross. And we're only going to talk about linear systems in here. You could talk about quadratic systems where one's a parabola and one's a line going through it and all sorts of other funny graphs. Yeah. And we're not going to, we've graphed parabolas by plotting points, but we're not going to talk about crossing with lines and getting intersections or anything like that. We're just going to talk about systems with simply just lines. So for today, all we're going to do, feels like I've been making you guys do all the work today for some reason. We're okay with that. This is in the big book. Page 409. It's exercise 17-1. Like 1 through 17, I guess is what the problems are. The odds. Graph them and see where they overlap. You're going to have to be careful drawing out your graphs. I think they have grid paper down in the bookstore if that helps you. I'm pretty sure the bookstore has. I know Walmart has it if you go in their stationery section and look. I used to have some, but they told me to stop photocopying it and giving it out because, well, you'd give each student like 40 pages to get through a year.